Hello, welcome to your lesson on atomic structure. A lot of this is probably going to be a review of what you've seen in grade 9 or 10, but it's all a really important basis into what we're going to be talking about going forward. So this video here is to make sure you guys understand those important concepts, and if you need more practice on them, there'll be worksheets provided so that you can make sure you understand what we're talking about. So the first thing is, what is an atom made of? You've probably seen a picture like this before of an atom, and we can see here it has three distinct parts. Each of those parts are subatomic particles. And they are, of course, the electrons, which are found sort of floating around the atom along the outside and have a negative charge. And then there are the neutrons and the protons, which are found at the center of, or making up the center of the atom, which we call the nucleus. And neutrons and protons have a neutral and positive charge, respectively. This table here summarizes all that information, and we also shows us symbols that we use, like for a shorthand version of writing protons, neutrons, and electrons. You've probably seen the electron one before, where it's an E with a superscript of a negative sign. And then we have their masses here as well. So these masses in kilograms are also found in your data booklet, but they're also really big numbers in terms of not size, or actually really small numbers, sorry, but they have a lot of decimal places. So usually when we talk about them in terms of the mass of an atom, we use relative mass. So the relative mass, which is in AMU or U, in kilograms, would be the mass of a proton, which is 1.62 times 10 to the negative 27. But in relative mass, we just say the mass of a proton is 1. So then comparatively, because the mass of a proton and a neutron are so similar in relative mass, a neutron is approximately 1. And then an electron is much, much smaller by a lot of decimal places. We can see here in terms of the relative mass. Then when we actually talk about the mass of an atom, we basically ignore the electrons because they're so much smaller. It doesn't really how many you have doesn't really impact the actual mass. Instead, it is just the protons and the neutrons that make up the mass of an atom. Here we have atomic notation, which you've probably seen before. We can write it as having X, which is our chemical symbol. So, for example, for oxygen, it would be an O. The A, so the number on top to the left, is the mass number. And then Z or Z, the number on the bottom to the left, is the atomic number. And just with atomic notation, we can instantly find out the number of protons, the number of electrons, and the number of neutrons that are present in an atom. So for the number of protons, that's just equal to the atomic number. The atomic number is literally how many protons are found in the atom. The number of electrons is equal to the number of protons, because if you have an uncharged molecule, so not an ion, then you have an equal number of protons and electrons because the molecule does not have a charge. And then the number of neutrons are equal to the mass number minus the number of protons, or the atomic number. Because as we just talked about before, the mass of an atom is made up of its neutrons and its protons, because electrons are so small. So if we know the mass of if we know the number of protons and we know the mass of the atom, then we can find out the number of neutrons. It's just a simple subtraction. So just to show an example of this with carbon, we have its chemical symbol, which is C, its mass number, which is 12, and its atomic number, which is 6. So we see the number of protons, it's equal to the atomic number, which is 6. We have the number of electrons, which is equal to the number of protons, which is 6. And then we have the number of neutrons, which we know the mass of carbon is 12. And 12 minus 6, which is the number of protons, is our number of neutrons, which is 6. And that's everything. Thank you for listening to this one, and I hope you have a good day.